Okay, so hello everybody. Thank you for joining this webinar entitled Consumer-Driven Contracts in Your Microservice Architecture. Before we go to the main topic, let me say a few words about myself. So my name is Marcin Grzejszczak. I'm working for the Spring Cloud team as a developer at Pivotal. I'm working mostly on free projects, so Spring Cloud Sleuth, the Spring Cloud Contract, so the one that we're going to talk about today, and the latest one, Spring Cloud Pipelines. My Twitter handle is @mgrzejszczak, and my blog is toomuchcoding.com. I'm pretty sure it's impossible for you to type my name, so you can find my Twitter handle at my blog site, which is much easier to memorize. Okay, so what's on the agenda? Agenda is very simple. So basically, there's going to be an introduction, then a demo, and a summary, and nothing complex. Okay, so ladies and gentlemen, may I have your attention, please? Since there's like in the internet quite a big commotion related to what contracts are, what is consumer-driven contracts and stuff like that. So the first thing that I'm going to talk to you about is what we will not be talking about. So we're not going to talk about schemas, WSDLs, ESBs, XSDs, XSLTs, and stuff like that. It's not going to happen. So the idea of Spring Cloud Contract is not to introduce any unnecessary coupling or replicate old mistakes, right? We've seen some things go wrong. Spring Cloud Contract is not like reinvention of the same thing. And why? I'm going to show you that in a second. Okay, so in order for us to be on the same page, we have to use the same vocabulary. So let's define some terms that we will be using throughout the whole session. So a producer. A producer is a service that exposes an API, right? Simple stuff. Then we have a consumer. Consumer is a service that consumes the API of the producer. So if you are sending a request to another service, then you are consuming that service's API. What is a contract? A contract is an agreement between a producer and a consumer on how the API will look like. It's a written statement. Typically, some companies write those down in documents like Word or Confluence pages. We don't want to use that. We need something that can be inside code and that can help us bind those sides to this agreement. Now, consumer-driven contract is an approach where the consumer is driving the changes of the API of the producer. What does it mean? It means that since the consumer is the one that is using the API, that's why it's called a consumer, it knows best how the API should look like. And how it's done in practice, you're going to see during the demo. So whenever somebody tells you about a new tool or a new approach, the first thing you should always ask is, what problems are we trying to solve? Because often somebody hears a new slogan, new tool, and immediately somebody says, let's use it in our company. But if you cannot answer the problem, like what kind of a problem will this tool solve, you shouldn't be using that. So what problems are we trying to solve with Spring Cloud Contract and consumer-driven contracts as such? The first one is stub validity and reusability in the integration tests. And now, what are integration tests? So we are on the same page again. So when I use the phrase integration test, it means a test that is run during the build time. So you're building your application, and some tests are, let's say, working on mocks and stubs and stuff like that. These are unit tests. And integration tests are those tests that send real requests to fake HTTP servers or access in-memory database. So I'm talking about the latter tests. The second problem we're trying to solve is creation of a nice API. So we have a typical situation. We have a consumer that is sending a request to the producer. I guess typically this is how your production looks like, more or less. Maybe you have more services. So how would you write a test for this particular scenario? So the first approach could be exactly the same thing. So you run your consumer app, you run the producer app, and you perform end-to-end tests, which is often fine. But if you have microservices, or if the monolith is very hard to actually run, if you, for example, have monolithic applications, then basically, you can have different sorts of problems. Like on the producer side, how do I set up the database? Do I need some special tables in that database? Do I need more services? Should I stop something like manually? So there's a bunch of problems typical to end-to-end tests. So another thing that you can do is that the consumer is talking to a stub, right? Why would you want to do this? Because you will have much faster feedback because it's run during the build time, right? So let's check this example in more details. Let's say that the consumer application is called Pivotal Calculator Service. And what you can see here is the consumer application, right? And it contains some JSON mappings of HTTP server stub. So the examples you're going to see in a second are using the WireMock, which is a tool to stub an HTTP server. So it's using some stub definitions from WireMock, right? So we're on the consumer side, and the consumer owns the stub definitions. This is very critical. I, as a consumer, I'm writing tests, and I say, I define how the producer should behave. And what does it mean? What is this stub? Let's check it out. This is an example of the stub definition with WireMock. So you have let's ignore the priority section. It's completely irrelevant. We have request and response, right? So like with Mockito, for instance, you say that given something, return some value. So this is exactly the same thing. So if you're sending a request with a method post to URL history, then the response should be with status 201, and content type header should be equal to application JSON. Another example, you're sending a HTTP request with a method put, URL would be history, and body should contain a value like 5+5. And then the response will be having status 200. There will be a JSON inside the body, result 10 count 42, for example, and header is content type application JSON. Last example, you're sending a post method to URL history. Body should contain a value, text value 6+6, and then the response should be 400. So like given some condition, like how a request should look like, then some response should be sent back. So let's focus on this example. I, as a consumer, have this JSON file where I define how the producer should behave, and I have this URL history. So how about I just change it from history, the URL from history, to some non-existent URL? Why not? I can do it because I own the stub. So basically, it's kind of trolling, but I can do it. So what happens now? So I change the stub definition. So I'm saying that the producer will behave in a different manner. My tests will fail because I'm shooting a request and a non-existent URL, right? So in my production code, I was saying that I'm going to shoot a request /history. But now my stub is saying, hey, there is no such URL. I have some non-existing URL. So I rewrite my code to work with the newer URL. I just changed that URL. Now the unit and integration tests pass because I fixed my implementation. I fixed the production code and I fixed the test. And now, since in the deployment pipeline, I went through the build phase, I'm deploying the application to an environment where real integrations take place. So we have a couple of deployed applications and some end-to-end tests will take place. And now, obviously, I have nothing to worry, right? Because my build is green. I passed the test. Unfortunately, that's not the case because the moment those tests are run, there was going to be a disaster on this environment. Like hopefully it's some staging, and not production. So what did go wrong? Let's check it out. Stubs that were used in the build phase have nothing to do with the real API. I've arbitrarily changed the URL to some non-existent URL, my test passed. How is it so? Because since the consumer is owning the stubs, I said that, hey, when I send this bizarre message to non-existent URL, we have unicorns because the result is okay, because the stub says, yeah, sure, go ahead. So the response will look like this. But in reality, when I was sending that request to the producer, let's say during those end-to-end tests, the producer said, what? There is no such endpoint for 104. So the problem that we're trying to solve is stub validity and reusability. The problem was that stubs reside with the consumer. Consumer controls the stubbing process. So how can we ensure that the stubs are valid? Because the consumer can write, as I've presented, any stupid thing it wants, right? So this is one thing, like validity and reusability. So in one of the projects that I was working on in one of the companies, we had a SAN architecture because we had a monolithic app in the middle and plenty of microservices talking to it. So every team had to redo the same work. So they were stubbing the monolith. And the problem was that the moment they created those stubs, they were completely outdated because the monolith has changed in the meantime. And of course, the stubs weren't shared between the teams, so everybody did the same work. So that was the first problem. Another one is nice API creation. So the consumer is called a consumer because it's consuming the API. And it's called like this for a reason, because it knows how the API should look like. Thus, they should take part in the creation of the API of the producer. Often, I would say in the majority of cases, what happens is that the producer team says, good morning, this is my API. If you don't like it, don't use it. And the consumers say, hey, but this API is like impossible to use. We can't work with it. Can you please change it? And typically what the producer team says is, sorry, but we have a tight schedule. You can talk to our product owner. We'll put it into our sprints, and maybe in half a year we're going to fix it. So that's not the way to go because everybody is unhappy. So the producer's API change should be driven by consumers because the consumers are using the API. So this is something that can happen if there is no cooperation, right? The unit test passed, but altogether it doesn't fit, right? The consumer and the producer didn't meet somewhere. Another example is something like this. So we thought that the fields should be ABC, but in fact they are DES. So yeah, we have a problem. So we have to fix this problem somehow. So the potential answer to this problem is actually Spring Cloud Contract. So the best way to show it is to code something. So what are we going to code actually? So the consumer will be an application that receives beer requests. Somebody comes to the bar and says, I want a beer. So the consumer app will receive that request and it will have to ask another service about whether the client is eligible to get the beer. So the consumer will send a request to the producer that will say, I have to check if the client is old enough to get the beer because to put things simple, let's say that the age will be the parameter that will define whether the person can get the beer or not. So the feature is that if the user is too young, the beer will not be sold. And otherwise the beer will be granted. For simplicity's sake, let's say that if somebody is 20 or over, he's going to get the beer. If he's below 20, there's no chance for getting a beer. Let's do it like this because it's simpler to write a regular expression. So let's keep with that. So how does it look like? Somebody comes to the bar and says, I'm 22, give me a beer. So the consumer app has to ask, hey, can he get the beer? And the answer is yes. So the consumer says, there you go. And second feature, you have the consumer and the producer, and somebody comes to the bar and says, I'm 17, give me a beer. So the consumer asks the producer, can he get the beer? And the answer is no, so we say get lost. So typical stuff that happens in a bar. Now, important thing, because I've been giving this talk a lot of times, and I think this is the best way to differentiate between the consumer and the producer. So whenever you see a black terminal or a black IDE, that is the consumer side. I'll be also repeating that we are on the consumer side. Whenever you see a white terminal or a white IDE, it means that we're on the producer side. Okay? So, time for the demo. Let's go to the code. So, this is our consumer application. Since we don't have that much time, I have already some skeleton of the code ready. I have almost no production codes. I'm going to show you that in a second. So, consumer-driven contracts is actually like TDD on the architectural level. What does it mean? Like when you're doing TDD, you start with a test and then things evolve. So it's exactly the same way here with Spring Cloud Contract, but the idea is that the API will evolve. So what we're doing is that we're starting with a test. We have two features to write. The first one is, should give me a beer when I'm old enough. And the second is, should reject a beer when I'm too young. So I'm going to copy some code here so I don't make any mistakes. We're going to use mock MVC to do the testing. Let me do some static imports. There you go. Okay. So the test is sending a post method, post HTTP request to the beer endpoint with an application JSON, and the request that we're sending is person. Person has a name and an age. So in this case, if I want to get the beer, I wish I was 22, I am not, but let's say that I am, then the status will be okay, and the response will be, there you go. This is our feature. And the second one is very similar, but I'm 17, and then what should happen is that I receive a get lost message, right? Get lost. So two features. You're over 20, you get the beer. You're less than 20, you don't get the beer. How does the controller look like? Like I told you, I've created some skeleton of the code. There's actually nothing here. So basically, we have a post method, beer endpoint, application JSON, and a person coming in. So at this moment, I should ask another, I should send a request to the producer to say, hey, like, can you check if the person is eligible to get the beer? But actually, the other side hasn't written a single line of code. If I wanted them to create some like fake API or something, it would take some time. So I want to experiment. I don't even know if the API that I'm going to pick is good. So how can we do that? And here comes Spring Cloud Contract. So sorry, the black screen. We're on the consumer side. Since during the demos, I really don't want to use the internet. So we're going to do a poor man's version of cloning a project. So right now, as a consumer, I'm going to clone the producer's code. Boom, like I've cloned it. So as a consumer, I have cloned the producer's code. Now, let me check out the proper branch. And right now, I will open that project. Yeah, so we're on the consumer side. I'm opening the producer local project. Let's wait for the, for everything to import. So right now you can see that there is no code here. There's only producer application, no controllers, nothing like that. So why did I do it? I did it because I'm interested in the POM, like in the properly set up project. So in the POM, I have a very important piece of code, which is this one. So Spring Cloud Contract Maven plugin. Why do I have it? You're going to see in a second. What I'm interested in is this part. So under source test resources, I have contracts. What are those contracts? We define that a contract is an agreement between the consumer and the producer on how the API should look like. And here I'm going to use this word for the last time, like first and last time, but it's not a schema. It's related more to a feature that we want to test, but it's also like you shouldn't have that many contracts as many features you have, because the idea of contract testing is to test the semantics and not to replace, like do the feature twice, once in the code and once in the contract. So here I've created two contracts. In Spring Cloud Contract, you do it with using Groovy DSL. So let's check out how the contract looks like. Here we have first case, so should grant a beer if I'm old enough. We have a factory method from contract class. And if any one of you is scared of Groovy because it's a dynamic language, I have to very much disagree, because it can be dynamic. And personally, I love Groovy when it's statically typed. So the DSL is statically typed. Everything you're going to see here are methods, are things that are statically typed. So the compiler will help us at every point of us writing the code. So let's say that I want to play around with the API of the producer. So let's say that the method that I would like to, let's say, use would be post. The URL, let's assume that it can be check, maybe. Why not? And I will send some body. In Groovy, you can use the map notation to define a body using Spring Cloud Contract. Basically, JSON is a map, right? I mean, it can have a list of maps, a map of lists. It can have everything, basically any sort of combination you can imagine. That's why it's very hard to work with JSON when you need to parse it. But what kind of a body I would like to send? So let's say that I would like to have a JSON where there's going to be a field called name, where the name will be Marcin, and the age will be 22. This is how I defined in a very nice, like readable manner, how the input JSON should look like. And now, time for the header. So let me create a header. Header key would be content type, and the value would be application JSON. So here I defined certain requests that I would like to be matched when taking into consideration the should grant a beer if old enough scenario. Now, time for the response. Since I don't want to do any mistakes, I'm going to copy it from here, and I'm going to explain you what I did. So the response is, I assume in this case to have status to 100. This is another way of defining a body using Spring Cloud Contract. So in Groovy, we can do a multi-line string by providing those three characters. So here I just define what kind of a JSON I would expect if the person is eligible to get the beer. And in the response, I want the content type to be equal to application JSON. There's some magic going on around here. Don't mind it at the moment. What we expect is that the response will have the application JSON content type, right? So here we defined a very simple contract that for the request with method post and URL check, if the body contains the name Marcin and age 22 and it's actually a JSON, we expect the response to have status to 100 and body having a JSON with a field status of value OK, and the header would be application JSON. So for the second scenario, what I'm doing is that the age, if it's 17, then the status should be not OK. So this is the part in which I, as a consumer, I'm playing around with the contract of the producer. But why do I even do that? What's the point? So let's go back to our terminal. I, as a consumer, I am in the cloned producer's code. What I'm going to do right now is I'm going to clean install and skip tests. Of course, you shouldn't be doing that with your like real production code. Right now, we're playing around with the API. That's why I'm doing it. And why is it so? You're going to see in a second. If we scroll up, you will see Spring Cloud Contract Maven plugin in action. So what happens is that Spring Cloud Contract Maven plugin is analyzing the contracts that you have defined and will convert them into the wire-mock stub mappings. So if we go back to the code, you'll see a target coming here. And in the mapping section, you will see a wire-mock stub. I have already shown you an example of a wire-mock stub during the presentation phase. So here you can see that the DSL was changed into the wire-mock JSON file. So here you can see that if somebody shoots a request with a URL check with a method post and content type equal to application JSON, and here you can see that we're using JSON paths to analyze the JSON. So the name has to be Marcin and H22. If that's the case, then the response should be 200 and body should be status OK and content type application JSON. So the first thing that the Spring Cloud Contract Maven plugin, Gradle as well, does is it converts the DSL into the stub. Another thing that it does is that it installs those stubs into your local Maven repository. So right now, as a consumer, I played around with the API of the producer, and I installed its stubs into my Maven local. Why did I do this? Right now, let's go back to the consumer's code. So we're back. This is our test. Let's see if it passes. Obviously, it will not pass because we didn't write a single line of the production code. Boom, of course it's not working. So let's write some code over here. I have it here so I don't make any mistakes. Hopefully I don't. Okay, so let's do some imports. Okay, so I'm sending a request using REST template with a post method to a URI localhost 8090 with a URL check, application JSON, and I'm sending a person there, right? And then I'm checking the status as we had in our acceptance criteria. So there you go. Will be sent back to the user once the status is okay, so the user can get the beer, and get lost will be presented if not. Let's see if the tests pass. Obviously they will not, and we will have a very nasty exception, which is IO exception. And it makes sense because I sent a real request to a real URL, but I didn't start any server, right? I mean, you saw everything I was doing. So I just added some, let's say, implementation, but I didn't start any server. So here comes Spring Cloud Contract on the consumer side. Spring Cloud Contract contains a module called stubrunner. As you can imagine, stubrunner runs stubs. That's why the name is quite good. So I'm telling stubrunner to work offline. What does it mean? It means, stubrunner, please find the stubs of my collaborators in my local Maven repo. That's why I installed the producer's stubs locally, because right now I want to play around with the API of the producer, so the stubs are installed in my Maven local. And here I'm saying the stubs that I would like you, Mr. Stubrunner, to download are those that have group ID, com example, artifact ID, beer API producer, with the latest version with the classifier stubs, and please register them at port 8090. So if we go back to the terminal, you will see that when I was installing the producer stubs, you can see com example, beer API producer, 001 snapshot, and stubs are here, the classifier stubs. So theoretically, what I would expect is that when I run it, stubrunner will download the stubs from my Maven local, will start a HTTP server stub and feed it with the stubs of the producer. So if I didn't do anything wrong, the test should pass. And they did. So what happened? Why did they pass? If we check out the console here, what happens is that stubrunner has resolved the version to be com example beer API producer jar with classifier stubs in version 001 snapshot. It has unpacked the contents of that jar and fed the WireMock server with the stubs and started this WireMock server at port 8090. So if you don't believe me, we can go to beer controller. I will put a breakpoint over here, and let's run the first case. So should grant a beer when I'm old enough. We're running the test. The breakpoint is here. And here you can see that in the response, in the body, we had status OK, and the header is application JSON. So indeed, it's working fine. Okay, so this was magic of Spring Cloud Contract, but the idea behind the whole flow is to play around with the API. So suddenly I say, it's kind of stupid that whatever I receive on my side, I'm sending to the producer, right? Same object. But the producer shouldn't care about the name. I mean, the only criterion should be the age. So let's say that I'm going to play around with the API. I don't like how it currently looks like. And the awesome thing is that I haven't written a single line of the implementation on the producer side, right? I just play around with the contract. So I'm going to send a request where I'm going to pass only the person's age. That's the only thing that has changed. So let us run the tests again. Let's see what's going to happen. Boom, the test failed. Why is it so? That's because I don't match the contract. So WireMock tells me that the closest match is the one that has both fields, age and the name, whereas I'm sending an age field only. So I said, hey, okay, fair enough. My bad. I've forgotten about this. So basically, it should ring a bell, this kind of situation where, for example, in the API, you've made a typo. So if you make a typo, your test will not pass because the closest match will be the one that doesn't have the typo. So we go back to the contract and we say, hey, I mean, the name shouldn't be there, right? Let's remove the name. What we're doing right now is that we will install the stubs locally from the producers. We're running clean install and we're skipping tests. Well, why we're skipping tests, you're going to see that in a second when we go to the producer side. So here, again, the stubs were created. If we check them out here in target, no longer do we have the name field. So if we go back to the consumer and we rerun the tests, I would expect those tests to pass because the name field is no longer required, and that's the case. So another thing that I'm doing is that if I go back to my test and I say, hey, actually, I would like this test to pass if I'm 50 and 10 as well. Of course, here, I'm kind of duplicating the functionality, but the idea is to show you that if instead of an age, you would have a timestamp or a database ID, you would have to, for example, coming back to this timestamp example, you would have to set like fix a clock in your tests to always set the same value of time in your example. So we wouldn't like this to happen, right? The contracts would be very rigid, and let's say we would introduce some coupling in the form that you would have to have very precisely created requests that can be like difficult to achieve. So what we can do, and right now if I run the test, it should fail because we would expect the values of age to be 22 and 17, and that's the case. So what we can do is use dynamic values that come with Spring Cloud Contract. So to do this, what I will do is call a method called value and say that the consumer would like to have a regular expression here. So if I'm old enough, it means that the value of age would be, the first digit would be from 2 to 9 and the last one 0 to 9. That's why I wanted to have this, like, if you're over 20, then you're eligible for the DIR because it's easier to write a regular expression. In case of if you're not old enough, the regular expression will look like this, right? So the request should be matched when the age is smaller than 19 or equal to 19. So what we're going to do right now is that we will run the installation of stubs again with skipping tests on the producer side. On the consumer side, but in the cloned producer code. So the same thing as we have been doing for the last couple of examples. And right now, if I run it and I didn't do anything wrong, the test should pass because the regular expressions will be matched. So they do. Awesome. So right now, as a consumer, I say, okay, I played around with the API. I'm really happy with what we achieved. This is the contract that I'm satisfied with. At this moment, I am filing a PR, a pull request, to the producer. So right now, we are going to the producer side. We're here. White screen, producer. And now we're going to go to the white ID. There we are. So we are on the producer side. And we have accepted the pull request. I mean, we have taken it over. So we didn't yet merge it, but we see a PR, and we're going to play around with it, right? I have, to speed things up, I have created a very simple producer controller where I have person to check. Person to check has only age. That's it. Nothing more. And the response will be having status equal to either OK or not OK. That's it. So what we're going to do right now is we're going to call clean install. I haven't written a single test whatsoever. Let's run it and see what happens. What happened? I haven't written a single test. So why do I have 2 failing tests? So, sorry. So what happens is that Spring Cloud Contract Maven plugin, except for the fact that it's converting contracts into stubs, it's also converting contracts into tests. So here you can see that for those 2 examples, like should grant a DIR if old enough and should reject a DIR if too young, it's creating 2 tests. These tests are completely auto-generated. What do those tests do? So if here we say that if I'm old enough, then I'm sending a method post, like a request with a method post to a URL check with certain body that matches a regular expression, then we expect status 200 and status OK in response. So actually, we are creating a request with header content type application JSON with age matching the regular expression, and we're sending the post method via post method to the check URL. And then we expect status code to be 200 and content type to match application JSON. And the cool thing is that we also check the body. So why do we do that? Why? Because if you're lying in your contract that things work like this, then we want this test to break. So my implementation is not prepared whatsoever to let's say be compliant with this contract. That's why this auto-generated test fails. So what I need to do is to write some implementation here. So if person to check has an age greater or equal to 20, then I'm returning a new response with beard check status equal to OK. I'm doing things iteratively, so I'm going to run the tests, the auto-generated tests again. OK, one has passed. So which one has passed? The one that is sending a real request to my controller and checking if status is OK. So let's write the second thing here, returning a response with beard check status equal to not OK. We're running this, and both tests pass. So right now, as a producer, I know that my implementation is matching what's written in the contract. I can prove it also by running the build. So I'm running the build. The auto-generated tests have passed, and I have installed the stubs locally. What is critical is to say is that these are the same contracts that the consumer was using to write his own tests. So we have one source of truth that is shared between both parties. So right now, what I would do in the real world is that once I merge the PR, a CI tool like builds the producer code and uploads the jars with the FAT jar of the app and the stubs to some artifactory nexus or something like that, right? Then let's now switch to the consumer side. Then inside my where is this consumer test, I would switch the work of line to false and provide a URL to my nexus, like my nexus or artifactory.com/libs release local, whatever. That way, whenever I build my app, like run the tests, the latest stubs, like the ones that you have provided here, will be downloaded, and my tests will be run against this, right? But since I don't have an artifactory here, let's go back to the working offline. So the last thing to show you is that if I go back to the producer code, then let's say that for some reason, I've decided to do a breaking change, which I shouldn't, but I am because I don't know why. I'm doing a breaking change. I'm changing the URL from check to beer check. If I go back to my terminal, clear, I'm running the Maven build. The auto-generated test should fail. Why is it so? Because there is no such endpoint having the beer check endpoint. So I get 404. So if I go back to the code and I fix the situation, like I fix the breaking change. I mean, I add the breaking change to the production code. If I go back to contract verifier, here I can see the new URL. So if I run those tests, they should pass. Okay. I go back to the terminal. I run the Maven build again. The test should pass, and I have installed the latest stubs locally. So right now, if I go back to the consumer code, if I run those tests again, what should happen is that those tests will break. So imagine the situation in reality. So the producer, by some mistake or deliberately, has uploaded the contracts that are breaking the backwards compatibility. Your test will immediately break because the closest match this time is a different URL, so the one that was broken. So in order for me to fix it, I would have to change the implementation. Okay, so that concludes the demo. Let's go back to the presentation. Let's do some sort of a summary. So what you could see is that we had that consumer phase 1. So the consumer has some offline work done in which it's playing with the API, like TDD on architectural level. is playing with the API until it's happy. The moment the contract is agreed upon can be the moment where the producer is writing its part. So these things can go in parallel. So the moment the contracts are agreed, both parties can work in parallel. So producer is implementing the feature, and then the consumer is switching to online mode. So let's look at the images. So we have an example like the consumer is to the right. Or to the left, we have a producer that owns the contract, right? So the consumer clones the producer code and works with the local clone. There is interaction going on between the consumer and the clone's producer to play around with the contract. Once the consumer is happy, it files a PR to the producer with a proposal of a new contract or a change or something like that. So it's all about TDD. So you write a test for the feature as a consumer. You clone the code locally to change the API. And remember, you install the stubs locally, right? So you clone the producer's code. You install the stubs locally. Then you turn the stubrunner to work in the offline mode because you don't want to download stubs from Nexus or Artifactory. You have to provide the group ID and artifact ID and version and stuff like that of the producer. If you go to Spring Cloud Contract documentation, you will see different approaches to versioning. Please check it out. And you do red, green refactor until you're happy with the API. Once the API is acceptable and the test has passed, you're filing the PR to the producer. Now, the producer takes over the PR, writes the missing implementation, and once the PR has been merged, the CI tool will upload the stubs and the FAT jar to Nexus or Artifactory. So we take over the PR, we write the missing implementation, and since we are using Spring Cloud Contract Maven plugin, there will be some auto-generated tests created for us, right? And we have to make them pass. We merge the PR, and that way we deploy, the CI tool will deploy the application and the stubs to Nexus or Artifactory. Then the consumer switches to online mode and then downloads the stubs of the collaborators during the build phase. So you have much faster feedback. Like I've shown you, you have to provide like works offline to false. By default, it's false, so you can remove that in the line. Of course, you have to provide the URL of the place where you store your artifacts, like Nexus or Artifactory. And you will have the test broken immediately once there is any breaking change. And here we go to a problem that emerges quite like often, is that one does not simply clone somebody else's repo. There are projects, there are situations where, for security reasons, you cannot clone the producer code. So what can you do then? The only thing that changes is that the contracts no longer lay with the producer, but they are in a separate repo. It's a normal Maven project from which you will produce a jar. So the consumer clones that repo and plays around with this locally. And once it's happy with the API, that repo has a very strictly defined structure. You can override it, of course, but there's some convention that allows you to do things very fast. Please check out the docs. I don't want to give you too much detail here because I'm just showing you an overview. And once the consumer is happy with the PR, with the contracts, APR is done to that repo over there. And then the producer, let's say, takes over the PR, so clones the repo locally, writes the missing implementation, and then once the PR gets merged, then during the CI, the producer is reusing the contracts from this repo that has all the common contracts together. And again, jar with the stubs and the FAT jar is uploaded to Nexus or Artifactory. So the only thing that changes is the place where you store contracts. So this is exactly the case when you, for example, due to security reasons. So what's important to remember here that the repo with contracts is also built by your CI. So it produces a jar with contract definitions. Then the producer downloads that jar. You can configure that in Spring Cloud Contract Maven plugin and finds its own contract definitions, either via convention or you can override it. The convention is that the folder with the contract for the producer lay in the folder that is group ID, artifact ID separated by slashes. The producer creates tests and stubs from those contracts. So again, we are verifying whether the contracts are valid against the producer. So nothing changes in this regard. The only thing that changes is the place where the contract lay. And then the producer deploys a fat jar and jar with stubs. Once the auto-generated tests pass, you have to put it into your CI pipeline. The consumer uses stubrunner to download the stubs from Nexus. This is exactly the same way as you have seen during the demo. Summary. So what did we achieve with Spring Cloud Contracts and consumer-driven contracts? So we've created an API that suits the consumer and the producer. Like both sides are happy. Expectations were defined by readable contracts, which means that the BAs can read those files, those contracts. Also, you have that description field there when you can provide arbitrary text. Expectations were tested against the producer. So if the producer is lying in the contract or is not meeting the contract, it will not build itself. So the stubs will not be uploaded. So nobody will be able to reuse them. You have to tell the truth. And since we are uploading the stubs into Nexus or Artifactory, everybody can reuse them. Starting and setting of stubs is fully automated. As you can see, you put an annotation, things happen automatically. So why could you use Spring Cloud Contract Verifier? So Spring Cloud Contract Verifier is the plugin, the stubrunner, all of that is underneath the project called Spring Cloud Contract Verifier. You can do CDC, consumer-driven contracts, also with messaging, not only HTTP requests. So you can define that such an input message can come and such an output message will be sent. And we're checking that against the producer as well. You have clear and easy to use statically typed DSL, and automatically tests are generated from that contract, which is really important. Stubrunner automatically downloads stubs at runtime. So you don't have to think about it. It happens out of the box. We integrate with Spring Cloud. So if you have discovery service, you're using console, for example, and you cannot do an in-memory console, you can use Spring Cloud Contract Stubrunner because it will stub out the service discovery automatically. So it will route to a proper WireMock instance for you. And we have integration with Cloud Foundry. So there is a project called Stubrunner Boot. So you can run an application, Stubrunner Boot, tell it to download certain stubs, and you can even tell Stubrunner to please register them in Eureka or please use a real RabbitMQ if you want to send, trigger some messages from contracts. You can check Spring Cloud Pipelines project where that's incorporated there, and you can check it out how it works. Okay, so that was it from my side. So now will be time for questions from your side. And yeah, so just whenever you have some doubts, just read the docs. You can check out the samples because we have in Spring Cloud Contract special standalone samples, which are real applications that can talk to each other and are using Spring Cloud Contract. And there is also the Gitter channel where we will be more than happy to answer your questions.
Awesome. Great. Hey, thanks, Marcin. And yes, there are a number of questions.
Go ahead.
So, yeah. Okay, so actually there are a whole bunch. So let's let's not spend too much time on each individual one. So hang on just a second. Sorry about that. First question comes from Andreas, our friend Andreas Evers from Ordina. And he says, if I understand it correctly, you're using the producer's repo and Maven build to install the contracts into the Maven repo. Pact is doing this with a separate Pact broker, which is an HTTP server that you can post and get contracts to and from. For the sake of decoupling, wouldn't that approach make more sense than having to clone a Java repo, run Maven, while your consumer could be written in JavaScript? And let's pretend that you're maybe not familiar with Java, Maven, or Groovy.
Sure, that's a very, very good question. Yes, that makes very good sense. So yes, I guess this question was asked before I shown the central repo. So partly it's answered. So it all depends.
I think
on
so.
Sorry.
It was asked.
But it's only to some extent, right? So it's only to some extent. It answers only to some extent. So the answer is that it's a matter of preference. I personally prefer when the contracts lay with the producer, but like I presented, it's not always possible. So this is the first thing. Another one is I personally like the idea of the broker, and I like Pact as such, because Pact gives you the possibility to, let's say, use consumer-driven contracts with different languages. So here we are kind of bound to JVM, and that was precisely the idea from the very beginning, because this is part of the umbrella project of Spring Cloud Contract. But we are planning to increase the integration with Pact. We are planning to allow you to define the contracts using Pact files. And also, in my twisted mind, I had an idea where the broker could work with the Spring Cloud Contract DSLs as well. So, to recap, it's a matter of preference. And right now, if you have a lot of different languages roaming around, Pact will most likely work more in a better automated way. But you can also achieve similar things with Spring Cloud Contract already, because you can use stubrunner boot to run the stubs of, if you have an Angular app, so for example, or Node.js app, and it's communicating with a Java app, for instance, then you can run the stubrunner boot and tell it to download the stubs that the Node.js app needs. And that's it. So you will have, again, the fake HTTP servers run, and the Node.js app will be able to communicate with these stubs. Actually, this was what happened in one of my former companies, that the UI was written with React, and the guys were using the stubrunner boot, so to say, option exactly in the way I've presented in their build pipeline. They had it incorporated in their build pipeline.
Excellent. Thank you very much. Yeah, that makes sense. And I think our next question is, hopefully, I think this one's pretty short. Can I have multi-level contracts defined to mock the integration tests?
Multi-level.
Multi-level
contracts. I don't exactly understand what multi-level contracts mean, but if somebody is referring to things like stateful situations, like scenarios, for example, then yes, you may have them. We do support scenarios, but I would discourage using scenarios because we do not want to replicate features, right? So what does it mean? Let's say that, coming back to this beer fraud check case, right? So if, let's say that we have 500 different ways of saying that the person shouldn't get the beer. Yeah?
Marcin, sorry. He's clarifying, and he says if I have a series of multi-level service calls. Does that
series
help?
Of multi-levels? Not really. So let's say series of. Can the person explain what multi-level calls mean? I mean, you can define any sort of requests and responses as you wish, right?
Well, he's clarifying further and saying service A is sort of calling service B, which is calling service C. I think maybe
no, absolutely not. Absolutely not. That's the very idea that we don't want to have. So we want to test in isolation. So basically, if you go to Spring Cloud Pipelines project, to the documentation, I explicitly write there like the very idea behind the, let's say, those stubbings. So let's say we want a faster feedback. So first thing is I want to test my app in isolation. I build it. So I'm calling service B. I don't care about service C. I don't even know that it exists. I don't care that B calls C, right? So I, as a B, let's say, consumer of that service B, I will like write only contracts that are like, I'm interested with, right? I wouldn't use this to like completely, I don't know, mock out the those multi-level scenarios. Of course, you can have stubs for like B calling C, C calling D. That makes perfect sense, right? Because you need some, you need those contracts. But I cannot imagine like having some more complex like stubs. The idea here is also that if you, I would encourage everybody to check Spring Cloud Pipelines, because over there, if you have good alerting, good metrics, good KPI monitoring, then you can actually get rid of end-to-end tests. Why? Because we check everything with contracts, so we are sure that the semantics is okay, that on production, you shouldn't have a problem with like the request is malformed or something like that. It doesn't mean, of course, that the feature is working, but if you have a very fast pipeline, you can immediately roll back to a previous version, right? So that way, maybe this answers the question to some extent, is that you can, if you're doing those contract tests and you have fast feedback and you can go fast to production and roll back to the previous version, you can get rid of end-to-end tests. You can do it then locally, like to be sure. I would do it as a developer, but you can get rid of them in the big pipeline.
Great. Okay. Thank you. Thank you. Let's see. I'm trying to keep up with the question queue here. Woof. There's a lot coming in. Luca asks, let's say that the producer is my client, and I don't have any rights to clone that repo. Then how can I manage it?
So we can have a common repo as I presented. So we can, like, if that is a client, then like we have two options. Either they cooperate and we create some private GitHub repo where they have access and both sides agree on some stuff. Or if that's not possible, I would ask them to provide a test environment with their test like app. I could write some contracts, but they're pretty useless if I cannot, you know, let's say exercise them against the client. I mean, that's the power of this tool, is that I'm checking if the contract is telling the truth. If the consumer is my client and they don't want to cooperate, they don't want to use the tool, then we have a problem. And what I would like, I mean, I would expect them to give me an environment where they have some sort of a test app that I can call with real requests. That's what I would personally do.
That makes sense. And I mean, that feels really realistic too, right? You know, because sometimes these web services, you know, they might be outside of the four walls of your business. That makes a lot of sense. Cool. Thank you. Enrique asks, hi, I would like to know how you would run the producer tests when the producer itself is a consumer of some other service and you don't want to have that dependency as part of your tests. Did you follow the chain?
Yeah, I mean, so maybe I will say it again. So I, as a producer, I'm calling somebody else, right? Okay, so that's a very, very good question. So let me go back. If I don't know if everybody can see me, like the code. I will be maybe showing that and talking at the same time. So basically, if you have a controller on the producer side, so we have those auto-generated tests. They are sending real requests. So here, for the sake of demo, I did a simplification, just to put it like, to say the least. So over here, I've created I wrote the real implementation. By the way, Peter, can everybody see the screen, right?
Yes. Sorry, I meant to give you that confidence. I just didn't want to interrupt you.
No problem. So what I should do is that I should do, for example, an interface called producer, let's say, service, with a method like response. Of course, it shouldn't look like this. It's like I'm doing it this fast. So check if eligible, check if okay. I don't know. Maybe I misspelled it. So, and we do person to check here. So what should happen is actually that we auto-wire a service here, producer service. Oh, we do it like this. We do return producer service, check if okay. And we mock this thing that we do not run the real logic. So if underneath I'm calling some real stuff, I don't want to be doing that because I don't want to check the implementation. I want to check only the semantics. So how do I do that? In the POM, you define the base class for tests. Either it can be one, or you can define a series of them, or there is a convention. So inside the base class, which I have over here, I'm doing a standalone setup for my controller. So actually, Oliver Gierke would kill me for doing this like this. So let me do it properly with a constructor. Yeah, so let's do it like this. So over here right now in the base class, I need a producer service. So what I would do is, let me do a poor man's version fast. I'm doing a producer service, Mockito mock of a producer service. And here I have to do all the givens and whens and thens. So for example, Mockito given, oh, I don't have VDD. So when producer service is called, I'm going to do some pseudocode here, right? So person to check with proper age, then return, for example, response would be new response with beer check status okay, something like this, right? And with improper age, then the beer check status would be not okay. So assuming that I would be calling some database underneath or something like that, I don't want to do it. I don't want to integrate with anybody else. It's a mock that should be present here in the producer controller. Like directly here, no real interaction should take place. I mean, this is my personal opinion, and it has some valid grounds, but I know companies that don't do it like this, and they use contracts to do some even end-to-end tests, but these are really like specific cases. What I would suggest is that you do not replicate functionality in the contract, and you do not make real calls underneath to a database or another service.
Got it. Okay, thanks for that. That's a really important clarification on the semantics versus the implementation. Thank you. Okay, and let's see. Okay, so we got that one from Enrique. Let's see. Roy. Roy? Wait a minute. Is that an I? Yeah. Roy Ezra or Roll. Excuse me. Sorry if I'm messing up your name there. Sometimes the service that I integrate with is serving data, for example. It's serving data. For example, sometimes I need to have tests that simulate different data sets for the producer for the test on the consumer. How can this be achieved? I think
sometimes I need to have different sets of data, right? So, okay, so I mean, for the same URL, right? So basically,
I would think,
right?
Yeah, I would think. Yeah, exactly. Simulate different.
So you can have different contracts
for the tests on the consumer. So
let's say you define let's go back to this beer situation. So let's say that you for some reason, and it makes sense for you, because the more contracts you have, the more it becomes a support burden, right? The mocks have to be okay. Like for the producer, it might become a problem if you have billions of scenarios to support, because you need to create those mocks underneath. So if, let's say, it makes sense, you can create for different, let's say, different requests, return different response. So what we did in one of my previous companies is we, for example, created different, because we had a scenario where somebody could be a fraud, and you can be a fraud for a number of reasons. Let's say, I don't know, 500 different options for being a fraud. So we picked 5 most important, and for example, we differentiated them by name. For example, if the client's name is, I don't know, fraud 1, then you return concrete status or something like that. So, I mean, this is test data, right? So then on the consumer side, if we needed, like, we could have picked one of those 5 scenarios depending on the things you need to test. But like, let me emphasize it again. If you can be a fraud for 300 different reasons, I wouldn't assume that you're going to have 300 contracts. I would assume you would have 2. So you are a fraud or not. Why? Because if you have a proper onion layer architecture, so then on the consumer side, those consumer tests would be like only on some tiny layer to see if we can communicate properly. The real like tests in terms of like, okay, you can be a fraud because of this, you can be fraud because of that. I would like mock out this call, right, to the producer. Why? Because I can have faster feedback, because I will not do real integration tests. I will not do real calls, and I can do it fast. So basically, you should have a lot of like unit tests, not that many integration tests, part of which can be the contract tests, right? I would really use them to check if we can talk properly instead of checking if the features are working fine.
Great. Okay. We're doing pretty good, Marcin. We're getting there. There's only a couple left. Okay. Let's see. Well, I think you kind of answered this already, actually. Alok, who was asking a question earlier about multi-level, chain contracts, is asking a question about, what happens if I'm a Java developer or the consumer is written in a different language like JavaScript. How can you use these contracts, with tests written in Spock?
Okay, yeah,
you
so
kind of
it's a very
addressed
good
this already,
answer.
so maybe we can go for a short.
To some extent only. I will only like give a fast answer. So basically, this is what Andreas mentioned. I can't believe that a JavaScript developer will not be able to install Maven. So if you have a Linux box, you do sudo apt-get install Maven, and then you just write Maven clean install -d skip tests. That's it, right? Because that way you will install the stubs locally. That's it. So I really do not believe that it can be a problem for somebody. Like if somebody can run npm install or something like that, the person can write Maven like Maven dot like clean install -d skip tests. It's very trivial. It's documented. I cannot believe that it can be a problem for somebody.
Fair enough. Yeah, that does sound pretty straightforward. Okay, and then Andrew Morgan from OpenCredo asks, could you auto-generate or infer contracts by interacting with APIs that already exist?
Oh, that's a nice one. So we were thinking about this, but you can have, it will not be trivial. Why? Because, for example, when you're using Spring Data, the API is automatically created, so to say, the controller. So that wouldn't be that easy. And actually, you don't want to stub everything. So, it's kind of problematic. But we were thinking about doing this the other way around. How about creating a controller from the contract? And that's something we have in our backlog. So imagine this, that the consumers are creating a new API, like completely new one, new URL or something like that. And then the producer, once it takes over the PR, like magically does something, and the Spring Cloud Contract plugin would generate the controller that matches that contract with fake data, for example, the ones that you provide in the contract. That would be awesome, and we're thinking about this.
Very cool. Oh my gosh, I can't believe it. We're getting close to the end here. Okay. I'm going to say his name wrong, so maybe I shouldn't try, but it's something like Dmitry from Bayer asks, when the tests run on the producer side, does the contract test actually call the intended endpoint? For example, testing a post endpoint would create an entity in producer DB every time. Now, I think the answer to this is no, right? Because you're calling the mock.
Yes, exactly. This is the answer.
Yeah. Okay. All right. I just wanted to be sure.
Yeah. So precisely,
okay,
that's
great.
the thing. You wouldn't call the DB because you wouldn't pass the controller because you're talking to a mock.
I'm just writing that in the console for him. Here, hang on. Okay,
okay.
Good. All right. Very good. Okay, excellent. Okay, so Youre, from a company name that I'm going to slaughter the pronunciation of, asks, in our example, we had a single consumer with a client contract and a producer with a server contract. But could our producer have a consumer contract with another producer at the same time? Let me know if you want me to read that again, because that got a little confusing.
Please do.
Okay. All right. Basically, he's saying, do you know that we know that I know that you know? No, I'm just kidding. In our example, we had a single consumer with a client contract and a producer with a server contract.
Sorry, we didn't have a consumer with a client contract, right?
No, I think he's saying I think in his example.
Oh, okay.
In his example, not yours.
Okay.
In his example. So once again, in his example, let's say, he had a single consumer with a client contract and a producer with a server contract. But could our producer have a consumer contract with another producer at the same time? I don't know if that's kind of hard to follow. But
clients, I don't know the concept here of client contracts. I would say it's an expectation, right? So, okay, I think I get it. So basically, that would be the case where you have a common repo. Like when you have a common repo with all the contracts, you can call those contracts expectations. Why? Because the consumers are putting under the folder of a specific producer how they would like the producer to behave. So let's say that we have a group ID ABC, and the artifact ID will be producer, right? And then we have 3 consumers of that producer. So in the common repository with all the contracts, we would have a folder A/B/C/producer, under which we would have 3 folders, consumer 1, consumer 2, and consumer 3. So all of those consumers would place their expectations on how the API should look like. So this will be one thing, right? So then the producer would, the test would be generated for him from this repo. But you could also have that producer have its own contracts on his side. So you can have like a two-faced comet, so to say. So you have the contract duplicated, if you need bigger safety. But I think it's like too much. So you should pick one of those approaches. And I don't know if I properly understood the question, so I'm shutting up.
I'm not sure if I did either, to be honest, because he just clarified and said with the client, I just meant your consumer example. So Youre, I think maybe this is an instance where you guys might want to collaborate on Gitter, because this format probably isn't best for trying to get this one out. Feels like a diagram is a good idea. Sorry about that. And believe it or not, I think we've run to the end of the question queue. Folks, this is a good time to look at your On24 interface and go down to the Resources tab. And then, excuse me, and then there are some links there with some follow-up information that you can kind of get a hold of pretty easily. Number of things like the blog entry about the release. There's an article from Martin Fowler on consumer-driven contracts. There's a link to the GitHub repo and a bunch of other really good stuff. Great. Marcin, I didn't have a chance to check this out, but I think this is a Maven download, right? So if people want to get their hands on actual bits, this is just a matter of plugging in some coordinates to Maven Central.
Yeah. So
is that correct?
Yeah. So basically, you're asking about the library as such, right? So it's more complex, right? Because there is a bunch of missing, like moving pieces there. So I would suggest going to the contract page, the Spring Cloud Contract page, and checking out the introduction. In the main page, you can see like all the dependencies needed by the producer and dependencies needed by the consumer. We do a step-by-step guide for this, so I would suggest going to the project page and checking it out from there, like what is exactly needed.
Okay, got it. So this might be more of an instance of let's clone the repo as opposed to let's plug into the Maven coordinates. Okay, very good. Alrighty, and then I think that's about it. If you are, if you're curious about what the next webinar we're going to be doing is, we're continuing kind of our microservice theme and distributed systems theme with Josh Long and Allard from Trifork, who's one of the main committers behind the Axon CQRS framework. And that's going to be on Wednesday, November 16th. If you would like to join us for that webinar, you can, there's a link to it in the question and answer panel of the On24 interface, or you can also just go to spring.io/blog, and you'll see a post. You just scroll down a teeny bit, and you'll see a post about the webinar. It's on November 16th. So please feel free to join us for that and invite your colleagues. And then, like I said, please register or subscribe to the blog or the YouTube channel so you get notification of the replay and the slides being available. And Marcin, there's a number of people just saying thank you.
Thank you.
And offering you some great job feedback, and one person saying hearing you is so much better than reading you, which I thought was cute.
Yeah.
So, anything you want to say?
So maybe I have to fix my writing.
So anything else you want to say before we call it a day?
Thank you very much. I'm really happy that we could have this discussion, these conversations. I really love to hear your feedback, because only if you give us feedback, we can make our tools better, and we do them for you. So without you guys, our job is useless. So please provide feedback. The topic of Spring Cloud, the consumer-driven contracts and contracts as such, is very it's kind of old because it's more than 10 years since if I remember correctly, since the blog post from Ian. But it's kind of complex, right? You can mix who is the consumer, who is the producer, but hopefully I've managed to explain that, at least to clarify some things and show what are the benefits, right? That we're not talking about WSDL 3.0 or something like that. That is something completely different, and it's solving real problems. So hopefully I've managed to show that.
Have a great day, everyone. Thanks, and see you in the webinar again soon. Take care.
Thanks.